Alright, so we're going to look at the zero product property. And really what we're doing here with that zero product property is you have to factor that polynomial, whatever you have, and then I'm going to show you what we're going to do with that. So you got to factor it in order to do the zero product property. And that's why at the bottom it says, sorry, scooting that up a little bit, we're talking about factoring and the zero product property. So first of all, you got to get your equation in standard form. You got to have the ax squared plus bx plus c. Once you do that and you set it equal to 0, you're going to factor whatever you have. Now, flip over to the front with me. We're just solving quadratics right now, so that's all we really have to worry about. There's not going to be anything bigger than an x squared unless we can pull out a GCF or something. Like we could take out an x, but we're just doing quadratics. I'm sorry, you can't see what I'm doing. We're just doing quadratics, so it's just going to be things to the second power until we get down to the very last page. And so this factoring and on the graphing, I'm sorry, we'll talk about that too. But anyway, on the factoring and the zero product property, you're going to get your equation in standard form. That means everything on one side, so that's equal to 0. And you're going to factor everything, and then you're going to apply that property. And all that zero product property says is that, and it's a little bit of common sense here, if you know anything about math, if you multiply two things together and they equal 0, then one of those two things has to be 0, because you can't get a product of 0 if you're not multiplying by 0. So, and we're looking for the, flip back to the front with me again, you don't have to flip, but pay attention, we're looking for zeros, so we're looking for everywhere that equation is going to be, when we put in that value of x, it's going to make the equation equal to 0. So we're looking for every x that's going to make my equation be 0. So when we do the factoring, flip back again, you're going to set each factor equal to 0, and every time you solve a factor for 0, that's going to be a solution. And you can check it by plugging it back into the equation and making sure that it works. So I'm just going to do 2 or 3 examples here. I'm not going to do a lot because we already know how to factor. We've been doing that forever, it feels like. So here's what I got. Sometimes you'll see it like this. And if you get it in that format, you're probably going to like that, or at least you should, because this one is already in factored form. If it's already factored, then all you have to do is set the two factors equal to 0. So let me remind you about some vocabulary. What are factors? Factors are things that are being multiplied. This is being multiplied by that. So you're going to set this factor equal to 0, and you're going to set this factor equal to 0, because in order for this product to be 0, one of these have to be 0. And you're looking for the zeros, you're looking for where the graph crosses the x-axis. So this is just like what we did with the square roots. You know how to do this already. You're just solving for the x squared, so you can take the square root of both sides. So I've got 2x squared minus 1 equals 0. So we're going to add 1. I think I wrote an 11 right there, sorry, because I got carried away. So I have 2x squared equals 1. And then we're going to divide both sides by 2. And so x squared is equal to 1/2. And then I have to take the square root. And so when I take the square root of 1/2, you've got the technology to use, so use it. You do know that it's going to be plus or minus. You're going to type in the calculator the square root of 1 over the square root of 2, which is going to give you the square root of 2 over 2. I'll show you real quick in case you have forgotten from yesterday how we do that. If you've got a fraction, you're going to go to the fraction mode first, and you're going to type in the square root of 2. Sorry, that's backwards. You're going to type in the square root of 1 over the square root of 2, and we get the square root of 2 over 2. So there's one answer. Actually, how many answers are there? I got a positive square root of 2 over 2 and a negative square root of 2 over 2. So there are 2 answers, and this tells me that I should have 2 answers. So those are 2 real roots. Now I'm going to solve this one. I'm going to add 3 to both sides. And I get x squared equals 3. And then when I take the square root of both sides, x is equal to plus or minus the square root of 3. So there's 2 more real roots. And that tells me that I should have had 2 answers. So there's 2 answers for this factor, 2 answers for this one. I've got a total of 4 answers that if I plug them back into this equation, they're going to make the equation equal to 0. Okay. Here's my next example. I'm going to have to write a little bit smaller, and I'm not going to squeeze it all in. So example 2, I've got this. X squared minus 4x plus 3 equals 0. This one is not factored. So if it is not factored, now that's where we have to do, use those math factoring skills that we've been working on forever. And this is just a basic trinomial with a lead coefficient of 1. So I'm using my x method, things that multiply to give me 3 and add to give me negative 4. And that's going to be negative 3 and negative 1. So I get x minus 3 times x minus 1. It's still going to be equal to 0. Once you get it factored, you apply that zero product property, which says that if the product is 0, then one of these 2 factors must be 0. And you just solve it for x. This one's a super duper easy because all I got to do is add 3. And all I got to do to this one is add 1 to get the x by itself. My equation says that I should have 2 solutions. I've got 2 solutions, x equals 3, x equals 1. And so I have a total of 2 real, sorry, that was bad, 2 real roots. That means that my graph is going to cross the x-axis at 1 and 3. It's going to look like that. And last one, I hope you didn't write terribly big or you're not going to make it this fit. I've got 3x squared minus 2x minus 5 equals 0. It is not factored. So let's figure out what kind of factoring we got to do to finish this out. If that lead coefficient is not 1 and I don't have a greatest common factor, then I got to bust the b. So I'm going to multiply 3 times negative 5 gives me negative 15. I need things that multiply to give me negative 15 and add to give me negative 2. So negative 5 and 3. So I'm going to bust the b. I've got 3x squared. I'm going to put the 3's with the 3's and the 5 with the 5. So 3x squared plus 3x minus 5x minus 5. And we got to group it. So if I put these together and I put these together, I'm going to do my shortcut with the grouping. I know that I'm going to get 2 sets of parentheses when I get through with the grouping. I'm going to pull out my greatest common factor here, which is 3x. I'm going to pull out my greatest common factor here, which is negative 1. And then this binomial should be what I get when I take out that GCF. If I take a 3x out of here, I'm going to get x plus 1. If I take a negative 1 out of here, I don't know why I said 1. That should have been a 5. If I take a negative 5 out of here, I'm going to get x plus 1. I'm glad I caught that before I went all the way through and finished it with the wrong answer. You probably were trying to tell me that I was wrong. Alright, so here we go. I got my 2 factors equal to 0. Apply that zero product property. This factor is 0 or this factor is 0, and I solve them. So, don't have a lot of room here. I'm going to add 5 to both sides, and I get 3x equals 5, and then I have to divide by 3. So, x is equal to 5/3. There's one of my, what should be 2 solutions. There's one of them. On this one, x plus 1 equals 0. We got to isolate the x. So if I subtract 1 from both sides, I get x equals -1. That is my second of my 2 solutions, zeros, roots, x-intercepts. I have 2 real roots. And my graph would look something like this. It's going to cross at -1. And 5/3 is what? 1 2/3? So there's 1, there's 2, so somewhere in there, my graph is going to look something like that. That says I have 2 solutions. I found my 2 solutions, and they happen to be real numbers, numbers we can put on a graph. I didn't draw my picture up here, but I could real fast if I needed to. This one's going to look a little bit different because it's going to cross that x-axis 4 times. Because it's going to cross 2 times here and 2 times here. So if I do the square root of 2 over 2, that's roughly 0.71. So that there's 1 and 1, -1 and 1. So I'm going to be here and here, close to -1, close to +1, and the square root of 3 is about 1.7. So if this is -2 and this is +2, it's going to be here and here. And my graph is going to look kind of weird. It's going to look like this. I'm not sure how far down it goes, how far up it goes on these two little, on the little roller coaster humps, but that's what it's going to look like along that x-axis. It's going to cross in those 4 places. That's all there is to the solving by factoring. You just factor it. Well, first of all, you make sure that it's in standard form, equal to 0. You factor it, put your factors equal to 0, and if you want to double check and make sure you're right, you can plug your solutions that you get back into the equation and make sure that it equals 0 when you simplify it. And that's all there is.